Good morning. Today I am presenting my thesis topic. It's a pre-defense. So the thesis topic is a unified deep learning framework for intelligent human activity recognition. So here is the introduction part, the overview of this project. So the project aimed to create the AI-based human activity recognition system designed to classify activities from video surveillance footages. It involved building a robust pre-processing pipeline capable of handling varying lighting conditions such as day, evening, and night. And also, it's a diverse data set, so there are some videos which include occlusions also. So the system extracts and enhances frames using lighting-aware pre-processing, motion analysis, and scene changes detections. So the proposed solution is I will utilize I also utilize using YOLO, pose estimations, and the customized I3D CNN to classify the human activity from video surveillance footage. So here is the problem statement. In security systems, detecting unusual activities is critical for ensuring safety and preventing unauthorized access. So traditional methods for activity recognition often rely on manual monitoring, which are time consuming, prone to human error, and lack of scalability. So below is the use cases: the security surveillance system, border control and perimeter monitoring, prisons and detention facilities, military and government installations. Also, the smart home. So here is the related work. The previous, they are using this model, the core approach, the data sets, and accuracy and strength. So mine one here is I'm just follow this paper. This is the core paper, the best paper for my work. So this dataset has custom while crossing video datasets, and previously it contains around about 426 videos, and now I have extended that datasets to 572 videos, and my accuracy is 96.1 at the validation accuracy, and the previous one is 95. So, and the strength of this project is it is a multi-pathway robustness to occlusions, interpretable, and real-time edge deployment. So I'm using these three models. In previous, they were using CML and HTML, and now I'm using the I3D TFNet, which is the customized CNN model, the pose rule, and handcrafted features. I'm using the three classifier, and lately I have combined it with the late fusion. So here is the data set and data pre-processing. So as I said, I have just extended the data set to 572 videos, and each class contain 2 to 8 videos per class. So first I have just extracted handcrafted features. Handcrafted features means load videos and extract frames. It contain the rich features from video frames to capture visual and contextual informations such as edge feature, height feature, texture features, color features, spatial features, motion context features, and entropy calculations. And with additions, the lighting detections, the frame preprocessing, frame padding, and lastly the advanced data augmentations. I just made my data set to more diverse, and I had some fog to simulate low visibility. I already addition some clouds to simulate overcast weather, and I'll already add snow to these previously videos using Python programming, and also adds rains to simulate the wet weather environment. So because of this, the diversity of the data set has increased. So here is the proposed data flow. You can see there is a video came from input video, and I just extracted the frames. Each video has 64 to 90 frames, and these frames I just extract the handcrafted feature, and then I train on these handcrafted feature handcrafted classifier, and from the extracted frame I'm just I'm using YOLO 11 to just crop the specific area of human with 20% margin, and on that cropped frame I'm using the 3D scene, the 3D customized serial model, and it will give me a classifier output. Also the handcraft also gave me an output. And after applying the YOLO, I also apply the pose estimation to that view body, to apply the rule-based logic. So the output, I'm saving it in JSON file. So lastly, I combine the three output in the head function, and it will give me the final output. It is activity is intrusion detections or not. It's a normal activity. So here is the overall data flow of this proposed project. So first I have just, as I can say that I'm just train the handcrafted classifier, so I will explain it and go through it from one by one. So here is the handcrafted classifier. Its purpose is I don't lose to I didn't lose the rich features to apply the 3D CNN. That's why I'm using the handcrafted feature here, classifier. So its purpose is capture rich raw frame level features from while classing and normal activity. So it's include edge detection and texture description, color histogram, and statistical measures. So here is the workflow. I'm using the YOLO, and then I'm applying the i3D CNN. So here is the YOLO model. As I previously said that I'm applying YOLO to detect the human in the video frames and crop the human area with 20% margins to ensure crops stay within the frame boundaries and skip empty crops. As you can see in this, here are two classes in my video data set. The one is normal and the other one is wall crossing. So it will detect human in each frame and just crop the human area from each classes, from each frame. So after applying YOLO, I just pass it through the pose estimation, and on this frame I'm applying the pose estimation model for human detection. So this one is the normal case and this one is the wall cross case. After that, after applying pose estimations, I'm just applying the rule-based logic. The first one is just YOLO detect the person. It expects 17 key points. Then calculate add key angle, just like hip, body angle, and analyze these movements pattern to smooth and repeat. It's a gate cycle. So if here is a decision logic, if they said yes or no. So they are checked for 5 indicators. If the horizontal motions, movements, consistency, and walking rhythm and angle range, these are normal. These are not changing. If they say yes, it's a strong normal pattern. So it should be normal activity. And in this case, if there is any horizontal motion is not like it's detect that it's a vertical moment. So it will be around about 2 to 3. Its post stability is not stable. So it will say no. So it will say no. So it will just pass it through the wall crossing analysis. And for wall crossing, they are again checked for 5 pathways. So it will look for the height, the high angle, very high height, moderate height, and sustainable activity. So after that, they are calculating the climbing score. If the climbing score is greater than 0.4, it would say that it's a wall crossing activity. And if it's less than 0.4, so the activity would be normal. So I'm just using, after pose estimation, I'm just using this logic in my project. So here is the 3D CNN. I'm using the 4 convolution layer and batch normalizations, max pooling dropout, and after that I'm in 3 layer fully connected layer. So the crop pose frame resize is 224 cross 224. Here is the 3D CNN architecture, and here is the results. Here is the results part, and first I'm just obtain the result for each class, individual class. So here is the handcrafted classifier, 572 videos, and include motion, height, variance, and pose based statistics. So first I achieved 87. Before I achieved 80%, then I gain again some pre-processing. So now its accuracy is 87% on just handcrafted classifier. So here is a pose aware rule-based logic classifier. Its accuracy is overall it's 86.88, and for each class, for normal it's 84, and for wall crossing it's 88. And this here is the i3D CNN. Its accuracy is 83.97, and informed score is 83.98. After that, I'm just combining these 3, the individual classifier, to alert fusion strategies. And again, I'm just 3 strategies implementing: the averaging, the weighted voting, and the staking. So here is the confusion matrix for each uh, averaging, stacking, and weighted voting. So in this case, as you can see, the stacking has the good accuracy. Simple averaging gave me 94.6, the weighted voting gave me 83.6, and the stacking, the majority voting, which gave me 96.18, which is the best accuracy in the previous literature. So here is the performance comparison individual versus fusion model, late fusion model. So the stacking fusion is the best model to achieve 96.18 accuracy. Here is the web app. As you can see that in this, I'm just uploading the video. And analyze each video or each classifier. They are predicting their own probability. This wall crossing or it's normal. If it said that all the three are saying that with the confidence 55%, 91%, and 94%. So each classifier just say that it's a wall crossing or it's normal. After that, here is the final prediction. And 81% confidence, this video is wall crossing. Here is the conclusion. So successfully deploy a comprehensive multi-technique fusion system for detecting wall crossing behavior in the video sequences and using the handcrafted rule-based and 3D CNN. And here is the future work to apply Kalman filter to predict the missing key points, as there are some key points in pose estimations which are missing due to weather condition or light changing or night conditions. So if we are just to improve the lighting detection and to apply the Kalman filter to predict the missing key points, so I think it should be improved the accuracy. Also enhance the rule-based component by adjusting threshold based on video characteristics, such as I'm using the 0.4 threshold, it's like normal activity or wall crossing. If we can change this threshold for somehow, so I think it should be increase the accuracy. Thank you.